Welcome to section 2.3. We're going to start talking about summary statistics that we can use to describe the distribution of data. We're going to start with measures of center. In general, measures of center ask the question, where's the middle of the distribution? The other summary statistic we're going to use, and we'll see this in the next section in 2.4, is how spread out are the data? Well, let's focus on this question, where is the middle? In other words, what is typical in this data set? And there's three ways to describe what might be typical: the mean, the median, the mode. If you haven't seen these, I'll define them. And if you have, let's refresh. The mean is what we often call the average. So you saw the summation notation in the last video. We take each xi as a number, is a data point, right? The value of a data point. We add them all up and divide by however many we have. Right? It's our average. We'll often call that x bar. That's what the left hand, that x with a bar above it on the left means. The median is a number for which half of the data points are below and half of the data points are above. If you know about percentiles, the median is the 50 percentile because 50% is below, and therefore 50% is above. If you have an odd number of values and you sort them from smallest to largest, the median is the one right in the middle. If you have an even number and you sort them smallest to largest, then you take the two in the middle and you just divide them in half. You average out the two in the middle, find the midpoint. Finally, the mode is the most frequent. You can have more than one mode, as we saw with multimodal distributions. Let's see how to find these values in Excel. These are the coin tosses from 2.1 that we looked at. As I mentioned, I generated these by their probability, but let's say this is our data. In other words, we've tossed a coin 8 times and recorded the number of heads. We did this, in this case to avoid rounding, 999 times, which really might mean we had a computer do this 999 times. 4 of those times we got 0 heads, all tails. 31 times we got 1 head, 7 tails, and so on. And you can see these numbers in column C. We made a graph. I turned this into something more like a line graph. And this is our frequency distribution out of 999 trials. And we can see in the language from section 2.1, this is a symmetric distribution. Well, let's calculate the mean, median, and mode. In order to do that, I laid out all of the values one at a time. So here is our 0 4 times. Then there are the number 1 31 times, and so on and so forth. So I don't want to highlight, we have 999 cell entries in column A, and I'm not going to highlight them all. So as part of this, you're going to notice a way to get Excel to do this without highlighting. So let's start with mean. Excel has all 3 of these as built-in functions, but you just have to know how to call them, right? What words to use. So as before, anytime we're going to use a formula, we start with equals. And for the mean, Excel calls that the average, which is what we usually call them. Now, the way I'm going to type this out is we put parentheses and then we type the cells in that we want Excel, whose values we want Excel to average. And since there's 999 of them, I don't want to type 999 of those. There's a way to tell Excel to go to average everything starting from A1 to A999. And the idea is you use a colon. So here's where I start, A1, colon, stop at A999. You will see that column A is highlighted as far as we can see, and if I were to scroll, you would see it's highlighted all the way down to 999. So I'm going to use that for all 3 of these, right, that tool. That's sometimes called the argument of the function. Anyhow, for Excel, we use the average function. The average is 4. Let's check the median. Median's the simplest of these. I simply type in equals MED. Notice Excel starts making suggestions when you start typing, and you see median there. Let's finish that up. A1 to A999. It's the same. It's 4. Wow. Let's check the mode. This one's slightly tricky. I'm going to start typing mode, and you'll see Excel has some suggestions, and if you highlight them, Excel will tell you exactly what they do. So for mode.mult, it's going to give you multiple values, whereas mode.single will give you a single value. So we're going to have a single value, and as before, put in our argument. And it's 4. So I hope you're noticing what I'm noticing, that the mean, median, and mode of this distribution are all the same. Can you think of a reason why that might be? Pause the video and think for a moment. Okay, let's take a look at the graphical representation of the distribution. As we noted, this distribution is symmetric. We can see that 4 is the mode because 4 is the most frequent observation, right? It's the peak, right? Peaks are our modes. But because we can also see that half of the observations are below 4 and half are above. So it makes sense that it's the median, and it's also the average. And the reason they are all the same is because this is a symmetric distribution. This is perfectly symmetric, meaning that the mean, median, and mode will all be exactly equal. With real data, I mentioned this is somewhat artificial, but with real data, it won't be exactly symmetric, but it'll be close. So all 3 of those quantities will be very, very, very close if you've got a symmetric distribution. So what about a skewed distribution? Well, let's take a look at another data set. This data set divides up the distribution among different households by income. So I highlighted in yellow the data set I want to focus on. So other parts of this table include data by different races, but I want to look at all races in the year 2019. That's the most recent. And so this data set tells you the percentage of households in 2019 whose income was under $15,000 a year. That was 9.1%. 15,000 to 25,000, it's 8%. 25,000 to 34, roughly 35,000, it's 8.3%, and so on. Recall from section 2.1 that we expect income to be distributed with a right skew, meaning there'll be a general hump, but then there'll be some extreme values to the right, some very, very, very high income earners, your Bill Gateses, your Jeff Bezoses, and so on. And while the percent distribution doesn't show this because eventually they just kind of give up and say, okay, over $200,000, we can actually see it in the median and the mode. So the median income in 2009 among all households was about $68,703 a year. The mean was about $98,088 per year. So these are very different. So what's going on? Well, what's going on is those extreme values in the right tail of the distribution are dragging the mean further to the right and making it larger, significantly larger than the median. In the next video, we'll illustrate how symmetry and skew impact the difference between the median and the mean.